Right, as promised, we're going to talk about calculations in chemistry, and we need to look at some of the basic numbers we will need. You may have heard this term before, relative atomic mass, which is given the symbol A subscript little r, and sometimes called the RAM, the relative atomic mass. This definition you really need to learn. There has to be some kind of scale on which we compare all of the masses of all of the elements. Now, we can't use the actual absolute mass because it would be tiny. So we have to use some kind of relative mass scale to compare them. So the standard that we use is carbon-12. Carbon-12 is taken to be the standard for this relative mass scale. And on this scale, carbon-12 is given 12 units. So carbon-12 is 12 mass units. And then everything else is compared in relation to that. So if we divide 12 by 12, we get 1. So 1/12 of this mass is 1 on this scale. Now, I know that's a little bit abstract, but don't worry about it. You'll get used to the idea. So the definition, the average mass of one atom of an element on a scale where 1 unit is 1/12 of the mass of a carbon-12 atom. Okay, so carbon-12, we divide by 12, that gives me the unit. So on that scale, the hydrogen atom has got a mass of 1. On that scale, the boron atom has got a mass of 11. Nitrogen has got a mass of 14. Okay, so carbon-12 is the standard and everything is compared with it. Right, some extra thoughts here. We just said carbon-12 is the standard, and we divide it by 12, and we express the relative masses of all the other elements relative to that particular standard. The relative mass, technically, because it's a relative mass, it has no units, although sometimes 1/12 of the mass of the carbon-12 atom is called an AMU, an atomic mass unit. And we use the word average in this definition because we have to take into account significant isotopes. So, for example, as you know, chlorine appears on your periodic table as 35.5. And that means we've got to take into account how much of chlorine-35 and chlorine-37 we have compared to the carbon-12 atom. So we need to look at this in a bit more detail. There you are. There's the relative abundances of chlorine-35 and chlorine-37. Okay, so for every 3 atoms of chlorine-35, there's 1 atom of chlorine-37. That doesn't mean it has half a neutron. Remember that. It's to do with the average, isn't it? Okay, so there's a relative abundance here, and we have to use some kind of mathematical construct to get the answer for the relative mass of chlorine. So there are 3 times as many chlorine-35s as 37. We can do a simple calculation. This is not required really for IGCSE. This is to do with A-level, really, but it's not that difficult to work out. If you think about this, if you've got 3 times the number, you've got 75% of chlorine-35, 25% of chlorine-37, divided by 100, you get 35.5. Okay, so the relative atomic mass of chlorine is 35.5. Don't worry too much about that, but if you've got a basic idea of how it works, it does make sense that this final answer will be closer to 35 than 37, doesn't it? That's the only important thing, really.